Okay, great. We have a smaller crowd, but this is fine. It's going to be fun. Thanks for being here. This is fun because, it's always great to talk to like a bigger audience, but I understand that quality is not necessarily the main the primary focus for most data scientists and data science teams. Unfortunately, I even have this slide here. This is usually the type of crowd that you see right now. So we're usually 10 to 15 years in lagging compared to software development. So this is a real problem. So how to make sure that we're able to have a good quality in systems. And by the way, I'm starting to get better and better to get crowd. So don't worry, it's going to be a fun. I'll try to make it as fun as AI system quality can be, but I'm sure it can be a lot of fun. So. And thank you, Peter, for the introduction. Maybe just to reiterate, so I'm one of the experts on the ISO standard. So it's called SC42. I'll go over that in a minute, a little bit later in the workshop. So I'm contributing to the ISO standard, but I'm also one of the editors for a standard on quality evaluation guidelines for AI systems. So I'll cover both. I'll cover the type of this standard on quality. So the main focus will be on quality, but we'll also talk about, okay, what's coming in terms of ISO standard for AI in general. So here it leads to these objectives. So first, we'll talk about quality evaluation. How can we improve what we deliver as an organization, as a data science team? We'll cover the ISO standards. Some people in bigger companies, they already are confronted with some ISO requirements. We'll talk about some of the ISO requirements, and we'll talk about what's coming. Because there's one certainty, so there's a lot more standard coming for artificial intelligence. Great. And if we have time, we'll do an exercise at the end. So we'll brainstorm together. Maybe just one note before I start. This is still ongoing. So this is hard. I cannot present anything from ISO. So everything's costly and everything's private because it's in process. So here what I'm saying is we'll brainstorm together, and what you see is not the 100% accurate. So I had to change a little bit some words and some concepts, but let's look at this from the objective, so what we're trying to achieve, and also it's to try to develop the mindset. Okay? Excellent. So here, first, why are we talking about quality? It's because most solutions are currently and will deliver poor quality. So this is just a fact. So we're estimating anywhere between 75 and 85% of solution, depending on the organization that studied the subject. So this is a big problem. This is a problem for different reasons. So this is a problem for adoption. The adoption of, if you're trying to deploy, when you have deployed a solution and it doesn't work, there's a problem. There's also a problem in the organization. So if you're about to deploy something and then, something's wrong. And at the end of the day, you realize it's the full system that has been wrong, for the full time. So it can be frustrating for the organization. So how can we prevent that? So in my mind, it passed by quality of the evaluation of the system. And also here, another problem we can see, and this is just a clear example of it. What's happening when you deploy a solution and it breaks when it's in production? So there can be a bigger problem. So Zello, I don't know if you're aware, so it happened during COVID. So I didn't have the opportunity to talk about this example, but I think this is a great example. So it's still unclear whose fault it is, so I'm not going to point any fingers. But what happened, Zillow, it's a big American real estate company, and they put forward a revolutionary model AI system that was able to predict house flipping opportunities. But after deployment, they realized that the system was just simply not working. So they had to revert back, they had to remove the functionality, and the company lost 40% on the stock market and had to lay off a bunch of people. So 25% of its workforce. So it can be really bad. So here, I'm not just going to mention like example all day, so we'll talk about different ways we can prevent this. So here I'll start by presenting some principles, and then after that we'll go a little bit into into some guidelines specifically. So one first principle I like to mention is what gets measured gets done. This is we usually think in data science we're good because we're data driven, but the fact is we're not really data driven when it comes the time to measure what we have done. So having a metric and say, you know what, this is great because I'm really good with my metric, it's probably not enough for you. So here, I'll come back to this example very often. But when we're talking about measurement, we're talking about a lot of different things. So here it's just an example. So you want to make sure that we call it functional specifications. So here, this is making sure that you are meeting the end user's specifications, okay? This is like performance is part of it. So imagine the only thing that we measure is a part of one characteristic. So if you're saying, if for instance you have a forecasting model and you're good at forecasting, you're meeting some requirements from the end user. This is basically what it means from a systems perspective. So we need to respect that, and we need to understand that there's a lot more to it. Like, for instance, adaptability. We'll cover that a little bit later, but is your solution working in the short term, or will it work for a long period of time? So there are different ways you can measure that. Robustness. So what's happening in various different situations. We'll also come back a little bit later. There are also a lot of very common requirements or characteristics like security. You could also talk about the speed requirements, load requirements, everything that a regular software developer is used to measure. But in data science, it's all new. Some data scientists, they're not coders. They're not software developers necessarily. So if you're only relying on software data scientists, these are still some requirements that we need to validate. So is it fast enough? Will you have a problem with the load because you have so many requests at the same time? So things that you need to ask. And also some things that are more difficult to measure, like usability. The output of your model, it's critical. If the output is unusable, then it won't work. So it's still part of the system, even though it's not like technical, and it's after it's after it has been delivered. So, and this is just an example, okay? Because honestly, there are so many other characteristics, and it's just a matter of being able to. So the way we should do it is you just identify all of the different characteristics, and then you find some clever ways to measure if you're meeting these characteristics or not. And then when you don't meet these characteristics, what can you do to make it work? Here, this is also a classic one, but from a methodology standpoint, let's make sure it's not because we're starting to explore other type of metrics that you're off the hook from a methodology standpoint. So here, just a small reminder, everything you want to do, please don't do it on the training data set. This is just like very common, but let's remember that. So we're still suggesting 3 data sets: training, training validation, And then every other test that we'll do, that I'll talk about, usually it should be on a test data set. Okay, and there are some requirements also, like from the test data set need to be representative of the situation of the real life. And it should not be, there should not be duplicates from the testing and validation data set. So here, you need to have the right samples, the right samples for your measurements, okay, that we just talked about and that we'll talk about a little bit later today. So this here, no, I don't really see, I'll explain it anyway, so just in case. Oh, maybe in the room, who's familiar with machine learning? Okay, great. So I won't explain this. Excellent. So I just wanted to make sure this is great. We don't have people who are beginners. It's okay. Great. So another principle that I like to mention is to challenge ignorance. This is also another funny one because data scientists were known to be curious. We want to be curious. We want to explore things. We want to find solution. But you know what? When we have an idea, it's like we want to stick with it. And this is a problem. So this is a problem because we are so biased. We're biased because of the hype. We're biased because of technologies, expertise. It's like you're comparing like correctness with complexity, and you found your model. It's like, oh yeah, it's complex, but you know, transformers, it's off the hook. Everybody's talking about it. It's a real, like, it's supposed to be game changer. So I'm just using those transformers, and like it's the best thing since sliced bread. But then you need to compare. If you don't compare, you don't know if it really helps if it really helps your end users. So here, for instance, would be two other alternatives. It's like the current state and a simpler alternative. You could also compare like a lot of different versions. Like I encourage you to compare as much as you can, but you should definitely always at least have one baseline to compare against. Why? Because here, this is what you think happens. It's like, okay, you gain a lot of, just by using machine learning, usually you gain a lot of performance. And then after that, it starts to slow down a little bit, but it still increases. Okay, this is our own bias. Usually, I'm exaggerating, but you understand what I mean. This is what can happen. So we often hear about, like, for instance, deep learning. It's sometimes too complex for some use case. So it's useless, and sometimes it overfits. Good example of that would be with forecasting. This year, there were a lot of studies saying that, like, XGBoost, for instance, could be better or equal to deep learning for forecasting. So if your plan is, okay, transformers all the way, you might be surprised to understand that there's no gain, but this complexity brings a lot of fallbacks. So you might not want to go there, but you don't know unless you try. Or even worse, that happens, and that's frustrating. Like, I'm in a consulting company, and sometimes some people, they say, you know what, I understand the subject matter expert, but I think if we use these variables, it's going to be way better. And then we realize that the subject matter expert was right all along. So sometimes you can get surprised that the current state is better than what you have in mind. So this is also something important. Here, why I'm saying this is just because there are no ways of really saying, and people have tried. So what's the real moment where you start adding value in machine learning? This is really hard. So you cannot say, okay, we need to have 92% accuracy for us to demonstrate that we're bringing value. So the next best thing is to compare. Okay, so this is why it's very, very important to do. Another way to be able to validate that everything's working properly is to validate from different perspectives. Here, the image is like, it's so pixelized, but I like the idea of like the giraffe looking at the hat. Anyway, it looks like a bullseye. Anyway, that's not important. So here, a way, so an example of what I'm saying here, talking about perspective, is a comparison between looking at global metrics and looking at more local results. Okay, so let's say, for instance, we have a model. The model has accuracy of 90%. So first here, accuracy, is it good? So maybe when we look at the model and we're looking at accuracy, is it a good measurement of your model? So maybe, who thinks it's a good measurement? Nobody? Who thinks it's not a good measurement? So I'll see whoever is really participating. Okay, so 2 people. The rest, you're all looking around. Okay, so. Okay, great. So here it's a catch. So 90%. It depends on but I understand what you're saying. 90%. It's quite high for some use case, but sometimes it's appropriate. And so when we say accuracy, sometimes we say, oh, you know what, accuracy is not good. Let's use AUC. Let's use F1 score. Here, we're not here to debate on what's the appropriate metric. So one task that you need to do very early on is to find the best metric. And the best metric, it's really based on the objective that you have. So here, the right way you do this is you understand the business objectives, and then you try to convert them into metrics that can be measured for your model. Okay, but even then, when you're just looking at one number, it's inconvenient for a lot of different things. When you have a lot of data and a lot of different contexts, it can be really misleading. So I'll present you an example that we did. And for the business people, this is also very difficult to digest. It's like maybe you risk your department's life and profitability because of one number that tells you that you should do it. It's like it's compelling. For now, it's still compelling because of the hype. But as soon as the hype will disappear, and then the business people that don't really understand, they will need to trust one number and say, okay, 94 or 72%, let's go. It's going to be a very tough salesman job. So here, instead, what we would recommend is to do something a little bit more sophisticated, like user acceptance testing, for instance. So this is a very good way to validate that it works. And by the way, in the quality evaluation guidelines that we developed, this is one of the recommendations that we do. So instead of looking at one metric, so what we'll do, so we'll break it down. So here, this is just a visualization of the progress. So for instance, here we have 20 test case. So 20 situation or 20 different contexts in which the end user needs the system to be working, okay? And you can see the progress. So at first, you were terrible. You were just meeting 5 out of the 20 test case. So you continue to work. And then at some point, you're at 13 on 20. It's not very good. And then you're continuing to work on it. Sometimes you will not meet 100% of the test case, and this is okay. It happens. But this is much more meaningful for the end user. And also on your side, you make sure that you met the most important situation for your client. Here I'll show you an example. So for the talk, so what I did, I look at the M5 competition. So the M5 competition, it's the Walmart forecasting competition from Kaggle. So essentially what the competition was about is being able to predict the demand in units for a bunch of stores and a bunch of products. Okay, just to simplify the job, we grouped the unit by store. So instead, we will look at different product. Okay, and we did 2 models. One is a simple exponential smoothing. Another one is a little bit more difficult, a little bit more complex. It's a LGBM, and we are going to look at the performance. Okay, so first, let's look at some global metrics. So what I did here, I did a graph. Obviously, I won't present this to an end user like a business person because this is still too complex. But you can see the metric. So the metric we decided to use is the MACE. It's the scaled, it's the mean scaled absolute error. Which is a very good metric for most forecasting project. Okay, so this is great because it's a ratio between the error and a dummy model. So what it means under 1 you're better than the dummy model, and over 1 you're like it's just crappy what you have because the dummy model is better. Okay, so here what we see is the exponential smoothing is not performing very well. So your average MACE is at 81%. So on average, you're a little bit better than a dummy model, but not that much because you see a lot of different. There's a big ratio of products that don't perform very well. Because you see here, it gets very high. So it means that some products are like 60% worse than the baseline. So this is not very good. While the LGBM, it's 75%. It's 75% MACE on average. So the lower the better. So here the gain is significant between exponential smoothing and the LGBM. So here what we could say is, okay, this is way better. Around 80% of the SKU are predicted better than the baseline. So it sounds like a better version, and it sounds like a good version. So we could be tempted to say, okay, let's go forward with the LGBM. However, here, there's a lot of different SKUs. There's almost 2,000 SKUs, 2,000 different articles at Walmart. So let's explore further, okay? And here, this is just to show this is the baseline. So we're way under the baseline with the LGBM. So it sounds like a better alternative, and it sounds like a good alternative. But instead, let's explore user acceptance testing for a minute, okay? So first, I like to start by asking questions to the end users. So, what should this project do? Or what should you avoid at all costs? So those were, 4 different questions. And of course, I didn't talk to the Walmart people, but at Moov AI, we did a lot of project on demand forecasting. So these questions, usually they come back. So first, will this work with the most popular items? Like if you're able to predict everything but my best sellers, I'll lose a ton of money. So we want to avoid this. Does the model predict well in general? So this is also something that's important. Are my daily sales close to reality? Because let's remember, we're talking about a model, yes, but we need to look to be a little bit more higher level. We're looking at a system that will help replenishment. So if you're not helping, if the way you predict doesn't meet the real daily forecast, the company will lose a lot of money. And also something else that's very specific to forecasting, but it's often the fact that a forecast can be very conservative, Why? Because you don't sell if you don't have any stock in inventory. So this is just like part of life. So Walmart, for instance, if Walmart doesn't have Doritos anymore on the shelf, they cannot sell Doritos. So by default, a lot of different SKUs will be conservative because they lost sales, and because of that, they are not able to sell anymore. So if you're more conservative, so usually you should be a little bit more optimistic in your prediction, because you try to compensate, and etc. So you could have a lot of different questions, and these questions will become objective that you'll try to solve, or you'll try to measure. So here, I'm taking these different questions, and then we'll try to define some tests. So the first test, and you see they can be really different. So the first step could be the maze for the top 10 items. So we just isolate the top 10 items and we look at those. The maze for the remaining items, the MAPE, so the mean, the percentage error by day to measure the daily sales. You can look at the negative error. So they can be a lot of different technique you use for measurement, but you break down your problem in smaller increments. And you can have different thresholds. So here, for instance, the difference between my maze for my top 10 items and for the remaining items is different. The threshold is different because it's much more important for business people to handle the top items than the rest. So you should be a little bit more aggressive, or you should be more precise for the top 10 items, etc. Sometimes it could be over than X, under than Y, depending on the type of test, and this is okay because they are all independent. So here, let's try to look into it a little bit. So just let's look at the popular items. So for instance, here you see there's a list. By the way, it doesn't have to be fancy for now. There are good tools that you can use, but there are not a lot of tools for machine learning, user acceptance testing existing on the market. But you could use, you could build your own logic. You can use Jenkins, for instance, to implement this. So there are different ways you can make it fit for your model, but this is something that you should consider doing. So here is an example. So you look at the top items, and then the LGBM is so you just passed 3 tests out of 10. So this is quite low. So it's a problem for us. Okay. When you look at all items, and here is a good comparison. So funny enough, but my model that was supposed to be good, like a 74% average MACE, was essentially just good because we were good with the remaining items. So we're not really good with the top items, but with the rest. That's a problem for us. So what it means that we probably need to go back, investigate why we're experiencing these issues, and try to fix the model. So here, what we would recommend is not go forward. And here is a summary, for instance. So in my test, so we had those 4 categories, and when you sum this up, you come up to 31% pass rate. It's very low. So depending on the problem, sometimes you could say, 75%, 80% passing rate on the user acceptance test should be a requirement. So here we would not go forward, and we would investigate quite a lot. Okay. So this is just an example of the difference between global performance and when you look from a different perspective, but this is something I truly recommend to everybody doing. Excellent. So let's talk about something else than just the plain model. So we spend a lot of time talking about the model, but let's look at the system instead. Okay. the model, it's a very small part of the project, of the system. We should look at it from a more holistic perspective. So even when you look at the performance, when you build a model, you usually build a model for like a very short amount of time. So it works right now, or it works with the data you currently have, and it works with the type of data that you currently have. So here, what you build might not be as robust or as adaptable as you think it is, because you're just building a model. And there's a difference between building that model and building a robust and adaptable solution on the long term. So here I'll just wait after this is, okay, thanks. But this is fine. There's some people, so just say, hey, I'd like to take a picture of it, and I'll stop. I'll wait. Okay. So here, let's talk about adaptability. System adaptability, it's how you're able to get from a static model that will work for maybe a day, maybe a month, you never know. There's some people in the forecasting industry, they say that a model that is trained now is already outdated. And usually what we do in forecasting, we tend to have a very frequent retraining strategy, okay? But here, I'll just go through all the different steps, and then after that, we'll discuss what are the different strategies that we can put forward to be able to solve this problem. So here, first, you need to monitor. And here, I'm saying correctness. Correctness is it's supposed to be the better term, because performance, some technical people think it's like the speed. So you should monitor the correctness, okay? And then when you find an issue, you should have the ability to assess what the issue is about, and to correct it, and then to redeploy it and integrate the solution. And then the solution is updated, and then the monitoring will be pursued, okay? So this is a typical continuous implementation, continuous deployment, continuous integration strategy. So here, I just gave away one strategy, but in the room, let me ask you some questions. So what type of solution or workflow can we put forward to be able to be better at to have a more adaptable solution? Do you have any idea? Could be a type of model, a type of approach, a process that you put forward. See the obvious, yeah, exactly, CI/CD. But you're right, textbook. And in fact, every solution should have a CI/CD in place. Sometimes it could be just the deployment, or sometimes when you don't necessarily have the budget, or the company is not very technical, you at least have monitoring with alerts when the model is degrading, and the ability to redeploy. But you're right, fully CI/CD is good. So what it means a CI/CD, it retrains depending on it could be a timing, or it could be when there's degradation that has been flagged. So let's say every day. So for instance, I'll give you an example. So we did a project with the Montreal Transit Authority to predict the ridership, okay? During COVID. So it was quite an interesting story. If you want, we can talk about data drift for a very long amount of time. So because every time the COVID rules kept changing, there was a lot of data drift. So sometimes it was very popular to take the subway station. Sometimes it was not. So we had to retrain every day. So what we did, so every day there's a trigger to retrain the model. And then you measure based on some KPIs that you have not broken the model. And then when you demonstrate that the model is as good or better, then you redeploy automatically. So it becomes just a workflow that gets run every day. Or it could be when you see that the model is degrading. So based on the metric, you retrain automatically. Okay. Any other ideas? let's say, for instance, what type of machine learning approach could we decide to go forward if we want to get better at adapting to the new reality? Like, no? Okay. Reinforcement learning, for instance, could be an example. So the reinforcement learning is it's adapting itself with reward and with trial and error. So it's an idea. Active learning is also another idea. Okay, but those two ideas, for instance, should still be backed up by CI/CD. It's important, but this is critical to have that, because otherwise, and everybody does this, they deploy something, and next thing they know, it doesn't work anymore, and they need to go back. But what's happening if you're not there, if you don't have budget, if it takes everything to just redeploy your model in production? So it could be a very costly model to have to deal with this. Excellent. So this is what I wanted to talk about, adaptability. Now let's talk about robustness. Robustness is also another interesting subject, because robustness in our mind, and here, let's remove the idea of the infrastructure robustness. I mean, it's really important to have robust infrastructures, like, for instance, having multiple virtual machines, having managed infrastructures. If you're using a cloud, it's often better than if you're using something that's more sketchy. If everything passed through like one computer and you're losing power, like, that's not very robust. But let's put that aside for now, and let's talk about the performance. Okay, how to make sure that you have a robust model. So that's how our system works. Okay, you have observations, and then your system. So you have a model that will then generate prediction, and these predictions are the results that you're looking for. But here, robustness, it's being able to deal with these things. So, sunny day scenario, everything is normal. So you train on some data, and then you get answers, and because the new data, the new observation looked like your training data set, all good, it works. And the more generalizable your model is, the better it is. So generalizable, it's a lot of syllables for someone who's not very good in English. The ability to generalize on new data, or to extrapolate or interpolate. So these are things that you can do. And I won't talk about the technique, like the technical ways you can improve your model, but there are ways to make it more generalizable. But at least here, we know that, okay, the data really looks like something you have the model has seen in the training data set, so it should be all right. But what's happening when there's error in the data, for instance? So we did a project for Metro, the grocery chain, and we used weather API. And all of a sudden, the weather API just switched the degrees Celsius for Fahrenheit. So the data was all messed up. It looks like a very warm day, and everybody was craving for steaks at that time because they wanted to do barbecues. That was not the reality. It was just a data issue. But how can you handle this to make sure that you're able to get good results? And here, I said good results, but in fact, it's just how to get meaningful results. And sometimes, if you have data problems, the good results is maybe an error and a log on the root cause of that error. Getting an error when there's a problem is better than getting a crazy prediction when you know there's nothing like underneath. You could have flagged that very easily, because degrees Celsius, with global warming, I don't think we'll reach 60 degrees Celsius for a while. So let's just, by creating some rules, we could have prevented that, for instance. Anomalies. Here we have the same. So it's a good point. data errors are anomalies, but there are some anomalies that are normal as well. Like outliers, for instance. It happens that you have a day, it's very, very weird what's happening. We saw this in Quebec, for instance. Every businesses were closed every Sunday during COVID, during a period of time. So every Sunday, every businesses were closed. So this is an anomaly. So let's not use our prediction when we know they will sell $0 of items. So it's okay to overwrite when there's an anomaly. And security attacks, you don't necessarily know it's a security attack, but at least it should be flagged as an anomaly and should be treated as such. So probably not returning results. I helped building a credit scoring at some point, and funny enough, but we were testing the algorithm, and the lower the age of the applicant was, the better the likelihood of that person repaying their loan. So the score was better. So we tested with people at 14 years old, 12 years old, and they always had better result than people at 120 years old. But it's illegal for someone under 16 years old to have a loan. So we could just have said, you know what, never return any prediction for people under 16 years old. So you can bound your model to make it work when it should work. So I talked a little bit about this, but when you have an extreme case, what you should do is a question here. This is a if-else scenario. You look at the boundaries. Could be the boundaries on the input, but also the boundaries on the output. So when it's very, very rare that you will get this type of prediction, you could flag it and say, okay, if it's within the model boundaries, you could return the output. If it's not, then you could return, it could be anything. It could be heuristic, it could be an alert, it could be a mix of these type of scenarios. So it can even happen that you have a very good model for some different type of predictions, but the model is not good for the rest. We looked at it with the M5 competition. We could have said, you know what, when the model is good, let's return the model, and when the model is not good, let's return heuristics, or let's return a simpler model. This is something we could do, and we could do it right there. So these are type of techniques, and by all means, this is not an extensive set of guidelines, but I just wanted to share with you some guidelines before we jump into ISO certification and stuff like that, because at the end of the day, these are the type of technique you can use to assess if your model is good enough to go in production, or should you do some additional work to make it functional. So based on this, these are concrete, so we can do it right now, but how to get started? So it comes back to maturity, okay? This is usually what we see in quality management. First, we're talking about chaos, okay? Everything's a chaos first. So remember the first AI model or the first machine learning model that you did. It was you were trying stuff, maybe it worked, maybe it didn't. The validation was approximative, let's say nicely, and you learn, and at some point you become a little bit more reactive. So at least you know that it will break, so you'll book some time afterward to make it work. You know, for instance, that when comes a time to deploy a solution, you will probably need 40-50% more time to fix the different bugs. You know, it's better because at least now you know that you'll make some mistakes. And by the way, it's okay to make mistakes, but we're still reactive. Okay, so this is very common. Most most people are in this stage. Okay, 10 years ago we would have said, most people are chaotic. Like we saw a lot of different things, a lot of different even research papers were like they were overfitting and presenting results. Like there was a lot of very, very problematic things. But nowadays people, at least they're reactive. So when they see something that doesn't make sense, I don't remember who said it, but like, accuracy 90%. Let me look into this. I'll validate because it's weird. I made this error before, and now I don't want to make it again. So this is like the current state for a lot of different organizations. So what we should get towards is the measuring state and the managed state. So what it means, you start measuring a little bit more. So it's more quantitative. You're able to know if your solution is pretty good, not good at all, very good. So the level of quality for your solution. And manage, it means that it's essentially proactive. So you're able to be very proactive about it and have a good workflow where every time you do a solution, you have user acceptance tests, you have robustness evaluation. Like you have these type of tasks that are very specific to quality evaluation of AI systems. And then you'll fall into the optimization at some point. Okay? If we go to if we're starting to talk about ISO, or if we're talking about other standardization resource, usually these are the type of things they can help you with. So they will help you to learn what are good practices. They will give you the tools to assess what you need to do. And then they will help you certify. Okay? Sometimes, and this is maybe just a perception, but sometimes we think that ISO is a big certification thing, and everything is towards certification. It will take years, and it's very painful. But look at it from another angle, okay? This is a toolbox, and yes, you can use the ISO standard to certify what you do, and sometimes it's necessary. Certification is necessary. It is necessary when you work with different. So some organizations are forcing their suppliers to be certified. For some application, it is necessary or will be necessary. Right now, we're a little bit off the hook from an AI perspective because we're working on it. But I'll talk in the next slide is about the other existing standard that we currently are sometimes forced to follow, okay? But the standard, they fall into these three buckets. And usually this is what we'll see. When we talk about the technical reports, this is because we want people to learn about the technology. You could also learn by looking at the other files because there's a lot of, it's a goldmine of information. But technical reports are made to learn the best practices in the industry. Then you'll have technical specification. Technical specification, and like this is a generalization, but usually it's a good tool to assess. It's going to be like the best practices. It will be the guidelines. It will be action driven. Okay, it will suggest you to do. It will suggest strongly that you do different type of action to be better. And then for the certification, then we'll fall into something we call an international standard. Okay, this is normative. So this is something so it's reinforced. So what it means, you will need to comply to it if you want to be certified. You can also be required to comply to a technical specification as well. But anyway, didn't want to mix things up. Usually it will fall in these three buckets. So here I talked about ISO a lot, but you might not be really familiar what ISO is. So what ISO is essentially like the UN, but for standardization of processes, process optimization. So it's independent. It's not. It's a non-profit, and it's non-governmental as well. We might be thinking that it's a government initiative, but it's like the UN. It's every country is having representatives into the ISO network. Okay, and they all work together. So this is why, for instance, on my initiative, I have a lot of contributors from Australia, Ireland, the UN, Taiwan, etc. Okay, the goal is to make the standards. So usually, and this is not validated. Like there are some exceptions, but usually it's going to be reinforced in a lot of different settings. So when you're working with governments, when you're working with really big firms, the ISO will predominate some other type of standards. Usually it's a foundation. So in the finance world, we hear about some standards like some industry best practices, like SR 11.7, for instance. Okay, this is one document that will have guidelines for critical banking application, AI application. Okay, so right now it's standalone. And at some point, we might be thinking, it's hypothetical, but we might be thinking that it will be built upon like the ISO standards, or it will be a complement just for the banking industry. It could be possible, okay? Because this is how it usually works with the other ISO certification. ISO 9001, I'm sure you have seen this on buildings. So this is essentially the same thing. The only difference is usually this is for operations, and here we'll talk about AI systems. So here, those are maybe three different, and like I just picked three, but you might already be working on some certification. Those are the classic ones. So system quality is a good one. It's a 25,000 series. We usually say it's a series. Why? Because there are so many documents. I'm quite a good reader, but like this is a lot of pages to read. So usually you really pick what you want to certify against, and you want to make sure that you're like it takes a lot of time to understand truly what is requested from you, and this is why usually it's a big task. It's a big project to be certified against, to be certified for an ISO standard. Okay, but system quality would be good. It could be there's something it's called Square system quality for Anyway, it's for IT system or software systems. So this is a common one. It falls under system quality. There's also the 8000 series for data. You will see this, the 8000 series, and I don't know all of the other documents, but you will have, for instance, like privacy, a series on privacy, a document on privacy, document on big data requirements. So a lot of different standards and technical specification are in this series. And the other one is the 27,000 series on IT security. I'm sure you saw this if you work with international companies, things like making sure that you're compliant from a security perspective. So you might be working on this as well, okay? But today I'll talk about the subcommittee just for AI. So we have a subcommittee, it's called SC42. I don't know why 42, but it's maybe the 42nd task group, but it's a subcommittee on AI. So how is it split up? So we are handling a lot of different topics. One is around data. So, and this is interesting because the 8000 series is already existing. So it's handling data as a whole, but here it will be how to better explore and exploit data for AI. So it's going to be a little bit more relevant to our field. Foundations, application. So the different application of AI. This is they don't reinforce application, but it's more like in the learn objective. So the ability to, so when you look at the different documents that currently exist or are in progress, it's very interesting. There's a lot of information for people who are new to the field to understand what's, the foundation of AI, how does AI work, what are the different applications. So they provided a lot of information for professionals to learn about it. There's trustworthiness. This is where I spend most of my time. So how to make sure that the system is trustworthy. Could be anything that's related to quality falls into that. Controllability, robustness, adaptability. Those are all subjects that will fall into trustworthiness. Okay, and then finally, a little bit different but still important, but computational approach. You see underneath, there's already, so if you go and search ISO AI, you will see 11 documents are already existing, but there's about 50 documents that are in progress or already done. A lot more documents are on the way. It's very active, the community. So, by the way, if you're interested in participating, just let me know. The community is really active, and we're always looking for people to help. There's when we say participating members, it's not like 35 people like in a room. It's 35 countries. 35 countries, and we call 15 observing members. So they're just not part of the day-to-day, but they're still voting, for instance, on some of the guidelines. So they're still part of the decision making. So what does it mean for us? So there's a lot of work, and we could be proud because in Canada we are part of something that's really important. So in 2020 we have started to work on something we call AIMS. AIMS, it's AI management system. So this is a standard. So these are international standards that will be used for certification. And it's almost done. So by 2023, it will be complete. And the Standard Council of Canada, so Canada is already putting forward a pilot project for certification of AI systems. Okay, so I'll take a little bit of time and I'll explain what it means. Okay, so when we talk about AI management system standards, what we're talking, so AIMS. We'll be talking essentially about these 4 different topics. So how's the governance around your model, around the organization? Are you working on the right thing? Is the team diverse? Is the team, so do you have the right process in place for the system to live, to be well designed, to live a good, to have a proper life cycle? Risk management. Have you handled properly the different risks? Do you have the right control in place? This is one of the most important aspects of this certification. Then we'll also have there will be some requirements around support and operations. So is your system supported well enough? And is it used properly? So when we talked about, for instance, adaptability, it falls into this. So if you don't have adaptability methods, then you will suffer from an operational standpoint. And then finally, the last piece is quality evaluation. So here, hence why it's very important to focus on quality. So how does validation work? So here are different roles. Okay. So first, there are the people who want to be certified. So if you're an AI developer, or if you're the organization that plan on using the AI, here there's a distinction because sometimes some organizations don't build these solutions internally. They make it like they transfer the project to a third party. Like at Moov AI, we help companies build solution. So our role is essentially to prepare and support the AI developers. So it really falls into the hands of the AI developers to certify. So if you develop a solution, so a lot of technical people in the room, so you might be having to deal with certification requirements. This is good. This is good because it means something. If the people don't know what they're talking about, it would be a very useless certification. So great. Then there's another role. It's the conformity assessment bodies. So it's called the CAB, but it's not like the taxi. The conformity assessment bodies is the organization that will certify you. Okay. Right now there's maybe one, but that's only participating to a pilot project. So it's called the Responsible AI Institute. So, but there will be other organizations that will be certified. So right now it's funny because you need to certify companies. You need to be certified. So the CAB, there are no CABs because nobody has been certified yet. And finally, you have the regulators. So where it comes from. So in Canada, it would be the Standard Council of Canada. They have the task to regulate, to make sure companies can be regulated. Okay, it doesn't mean that everybody need to be, but if I don't know, Pratt Whitney Canada or Unilever or an hospital might want to make sure every service providers are certified. And if they do, then the regulators make sure that there are standards and they are approach, and there are some CAB, so conformity assessment bodies, in place to facilitate the certification. So these are the three different roles that play a role into certification. And then the process, it will be looking. We'll talk really about like risk. It's very similar to a common risk management process. So here you look at the different risks, then you analyze the risk, you establish the different controls to make sure that these risks never occur, and then you test and validate and you document the whole thing. So this is how we think it will work, by the way, because it has not been built, but if we look at other standards, usually it works this way. So we could say that this is essentially what's going to happen. Excellent. Here, this is just a small process flow, but this is, you know what? Let's just skip this. It's basically what I just explained. Okay, great. So let's do a short hands-on exercise. Okay, it's going to be. So I'll need you to brainstorm. So I'll ask you some questions. I'm expecting some answers because otherwise it will be a long amount of time we will spend together. So let's come back to the example we used earlier. Okay, let's come back to the M5 forecasting competition. Let's say for a minute that we're Walmart. Okay, and we are forecasting demand to help to automate. Let's be really realistic. Let's automate replenishment. So here this is risky. So Walmart want to be certified. So want to make sure that we really thought this through. Okay, because if you're mistaking, if you have problem, then you might be causing a lot of profitability issue to Walmart. So here we'll just, this is just a brainstorming exercise. Let's try to think what are the different risks. What are the different, the biggest risk of poor quality? Okay, so here I brought some information for you. So if I'm asking the room, so based on, for instance, the AI system quality characteristics that we see, okay? What are the biggest risks that this demand forecasting for replenishment AI system could, I'll rephrase. What are the biggest risks for this system that we're trying to build? Anybody has an idea? Yes? Overstocking inventory. This is very good. So when you're talking about overstocking, so this is a specification. So the end user in the inventory management team is saying, hey, this is a requirement. We cannot have too much. We have constraints. So these constraints need to be taken into consideration. This is a good one. So here it would fall into functional specification. Okay. So this is a risk that is it an important risk? Do you think? So this is pretty important. This is important because you might not have space to stock. So realistically, it might not be the best idea to have 1,000 PlayStation 5 per store because you might not have the physical place for it. But also from a profitability issue, it also might be a problem. So here, it's a big risk. The probability, is it high? It's low? We don't know because we don't have the model yet, but it can be important. It can be very high, the probability that it happens, because it's machine learning, so anything can happen. The impact is very high, so the risk level will be a major risk. So it will be an important risk. So we need to establish controls. What type of control, what type of action can we do to prevent this from happening?
Putting constraints, it's like store-based constraints.
Store-based constraint.
Like an extra constraint, for example, for the age of people getting loans, something like that here for the maximum number of stockings.
This is a great idea. Could be done. You could even use machine learning, data science, and say, okay, what's the maximum amount of PlayStation 5 they got in the past, or PlayStation they got in the past, and you can do something like that. You can also, on the validation standpoint, you could also validate if your model has a tendency to overstock. So you should, in fact, it's not or. You should do the validation proactively. And you should create these constraints to avoid this from happening. This is a great risk. Another risk. Anybody has any idea of another risk? Yes.
I'm thinking adaptability. If your model doesn't follow like seasonal changes in sales.
This is also a good risk. A good risk. It's funny. It's an important risk. There's nothing like a good risk. But yeah, this is an important risk. Like I said at the beginning, for forecasting, the moment you deliver forecast, it's already out of date. So exactly, I agree. This is a risk that is important. So here, if we analyze it, so what's the probability of this happening? It's quite high. The impact. What's the impact of a model being outdated? It's random. It's degradation. So you're losing the signals that you have been using. So you're losing predictive power essentially. So can go either way. So yes, this is a big problem. And we could even validate. So you can test by training. And then looking, okay, a month after you trained, so what's the impact, and you could evaluate the impact. So yes, this is also a risk that is worth controlling. So what type of control can we put in place? I think we talked about that before. Any ideas? Somebody else? So to avoid a solution from degrading, are there any techniques that we could, or workflow? Okay, let's go. Yeah.
Reinforce your model, right? You could keep feeding observations into it.
You could use reinforcement learning. You could use active learning. So you add new data to it.
You want to make sure you have enough training data to cover all those things.
You want to have a good coverage. The better the coverage, the more accurate you will be to predict these. So these are valid tests. So these are tests that you will need to add to your testing strategy. So this is, you know what, if you're waiting at the last minute to do this type of exercise, it can be too late. You have to go back and find all of these. So these are very valid. Here, also, in the ISO standards, processes are really important. So in this case, it would be, okay, a good continuous integration, continuous deployment, or a good retraining strategy, a good retraining process need to be in place. A good monitoring process. So you need to have the right people in place to validate every time there's degradation on your model, the reason why. So those are type of controls you want to have in place to avoid that from happening. Okay? Yes?
So how do you define how you retrain? And I'm thinking of like a COVID scenario. Say before COVID, data is trained, right? So after, during the 2 years, how do they define the period you should train?
This is an excellent question. So how do you find the right retraining strategy? There is no one answer. It depends on the use case. It depends on testing. So in fact, here, let me go on a tangent, but I'll answer this. So in fact, it's not just one technique you need to have in place. I'll give you this example, okay? There's data drift. There's problem in the data set that makes your model not good anymore, okay? Degraded, full degradation. You need to retrain. You say, you know what? Let's just, the classic retraining, you retrain, it's even worse. It's even worse, okay? Step 2, I'll change the hyperparameters. I'll let him play a little bit, so I'll test 100 different hyperparameters, or I'll retrain 100 different times with different hyperparameters, and hopefully it's going to fix everything. It's not. Okay. You need to investigate. So you need to have a multi-step, or you have to have multiple steps implemented for this to work, because it will always happen. So here, the root cause could be that the data changed, or everything's, maybe it's just a rows of null values that you just get. Like it's null, so it should never have happened in the first place. And because of that, even if you retrain, there's nothing there to retrain, but it pollutes your data set. That happens, and that's why you need to have these multiple strategies in place. Something else also that you might want to have is you might want to have a plan B. So with COVID, when COVID hit, it was like very, very quick for some companies. Like for instance, we had customers in the telecommunication world. The day after, everybody asked so it was like in a matter of 5 days, every company, they asked their employees to stay home. So the pattern changed very, very quickly. And you couldn't adapt your model by retraining on the first day. But if your model is necessary for a process, you need to have a plan B. And the plan B is not just retraining your model. It might be heuristics, okay, or a human. Here, I think this is another control you need to make sure you have in place. If you're Walmart and replenishment is important, the toilet paper crisis. We had the big crisis of toilet paper. Walmart, they were dealing with that. Imagine the replenishment strategy with that toilet paper. Maybe right now they still need to make some corrective action in their data to avoid over-ordering toilet paper, and then you're stuck with too much inventory. What would you do with this? So at the beginning, if Walmart would have had a automated replenishment, so when COVID hit, they had to have some plan B in place to avoid that from happening. So, sorry, long story short, did I answer your question? Okay, great. So, essentially, this is the heart, this is the mindset. It has not been well documented. So there's not even one company that has been certified yet. But in 2022, we'll start to do the work. And in 2023, we will be ready with some 2023 or 2024. We will be ready with a certification process that will be in place. And if you want to optimize your quality management, if you want to optimize the quality of your solution, this is a good option, okay? But this is not required. Although this type of exercise we did, like I could have taken a lot of notes. Okay, yeah, we need to do this and that. This is a valuable exercise that we should do to assess what needs to be done. So you don't necessarily need to certify to all of that, but this is a good to-do list for the future, for the delivery of the initiative. So, in conclusion, so what we talked together in the document that I'm currently building, so it's a bunch of concrete best practices. Okay, this is not, I'm a startup, so I co-founded a startup, and I decided to be part of the ISO standard. This is pretty rare. I'm dealing with people from Microsoft, from Google, from Meta, but as a startup, I wanted to have something concrete, and this is something that we're able to get there. It's like these are tasks that need to be done if you want to have good quality. This is very concrete. And also, the type of discussion that we had today, this is going to be an input to the future certification that's going to happen. Okay, this is real. This is what's going to happen, and what it does here, it supports the adoption of AI solution, because if you're delivering poor quality, at some point we might, they might not see the light of day, and it might really create a problem, an adoption problem in your organization. And, so it's easy to lose faith in AI if you're not delivering value at some point. So we want to avoid this. So on that note, thank you very much for your time and for your participation to my small exercise. I hope it was useful, and I would be ready if you have any question for me. Yes?
First of all, excellent presentation. Thank you very much. This is an angle I've never had. I have a quick question. Do you know what's the adoption rate of the data and ID security and the third one, ISO certifications in Canadian companies?
I'll just find it. So this one. No, I have honestly no idea. I'm not participating to these committees. Maybe they have discussion within the committee, but I have no idea. Honestly, I don't see these certifications very, very often. Usually it would be for like the international companies, like the big scale companies. Yeah.
I work for TELUS Communications. It's the telecom you might know, and I previously worked for Belcan.
And you have not seen those.
And it doesn't mean they don't exist, right?
Yeah.
I've always been battered by the security team and the privacy team whenever I want to move data or migrate data, use data in cloud. But I've never heard of like a certification. Doesn't mean it doesn't exist. I'm just curious. Like, are they, why the regulators, like, do they have to follow these? If these are mandatory or?
These are not mandatory. For in most use case, okay, it might be in some case, but I don't know. I've been working with Pratt Whitney Canada. I've been working with the Metro, the grocery chain. I've been working on the municipal side. They never asked for certification yet. But some organization if you're dealing with something very, very sensitive, like helping build autonomous driving application in healthcare, I know healthcare is really regulated. So probably in healthcare, you might be confronted with these type of ISO standards. I know in Europe, it's more advanced in terms of regulation. So, but I hear you. We have the same thing. So I think though that the AI regulation will be more will be more popular here because we have a big footprint. So Canadian have built AIMS, and Canadian are currently building the evaluation guidelines for AI systems. So it will be discussed a lot on the web and in companies.